When we say join is us taking two separate data sets and actually joining them together or using them at the same time and aligning data by what we call keys. And why is this important? Well, in the real world, data lives in multiple data sets, different storages, different places. You can imagine customer IDs and name and information versus the actual sales. So there might be sales reports with their customer ID on it, but there's actually more sales information. So we're going to see why you want to combine multiple pieces of data. Welcome back. My name is Crystal Bray from PTO Coaching, and today is day 2 of our challenge, Unblock Yourself and how to pull your own data in SQL. And today we're going to learn joins and why they matter. So in particular, what we're going to cover today is inner joins, left joins, right joins, and then full joins. So you're going to learn all that today. We're going to put it into practice. So let's get into it. Before we get into SQL and the joins themselves, let's talk through what is a join and what does it mean. Well, when we start, we have table A and table B. And what we really want to do is join them and extend the columns of A and or B. So thinking about if we have table A and table B and we join them together, for an inner join, I might only look at the rows in table A where I have the same key in table B. So if customer ID exists in A, the customer ID also has to be in B, right? So that's called an inner join. In a similar manner, we have a left and a right join, where I have all the rows from table A and all their columns, and only column table B that match table A. So that's called a left join. On the other side, I can have all the rows from table B and all their columns, and only the rows from table A that match the key in table B. And then we have, of course, the full outer join. And this is just take everything from A and everything from B and just append those columns together to get the whole data set. So it's a full outer join. And as you can see, there's a couple of spaces left. Then we have these things called left join excluding the overlap, a right join excluding the overlap, and then a full outer join excluding the overlap. So you can get all these versions of SQL joins. But let's get into one example and slowly and in particular. So let's say you have now table A on the left. This could be a customers table. So you see customer 1, John, then Jane, and Trent, and Tish. And then we have their activity status, active, inactive, active, and their ID, 1, 2, 3, 4. Then we can have in the orders table, the ID of the customer. So 1 and you see 4, 3, 5, and then also their order, maybe pizza, salad, or rice, and the date they ordered it. Maybe they ordered May 2024 or July 3rd. So we can see that in A and B. And you notice there are some rows in A and IDs that do not exist in B, and vice versa. There's rows in B that don't exist in A. So first, let's do a left join. A left join. On the left join, I want all the rows and all the columns from table A. And then on the right side, I only want it when it matches. So, okay, let's see what's going on here. I actually have 2 Johns on the left side. Well, that's because there's actually 2 orders for ID number 1 on the right side. I mean, 2 Johns. For Jane, even though I have her on the left side, there is no accompanying ID number 2 on the right side. So it's going to be blank in those columns. And sometimes we call them null or empty. And then for 3 and 4, you see the same thing as earlier. We get Trent and Tish, and we also get 3 and 4 on B side. What we don't see from B is we do not see row 5 from table B. Now let's do a right join. In a right joins case, you're actually going to see all the table, all the columns and rows from column B, but on the left side, you're only going to see column A when it also appears in table B. Now let's do a right join. In this case, I want everything from table B, all of the rows, and then I want to append the columns to table A only when B.ID is equal to A.ID. Well, I see here, okay, great. I see everything on table B as expected. And from table A, I'm only seeing John, Tish, and Trent because 2, Jane is not, her ID does not appear in table B. But also I see there's an empty customer row from table A for customer ID 5. So B.ID 5 is empty in table A, but I'm still going to bring it in because everything in table B is in the right join. All the rows in table B are in the right join. So, okay, great. Well, next, let's look at an inner join. So we've seen left, we've seen right, but what if I only care if I know the customer and I know their order? I only want those customers. We're going to go through again, and now we see an even shorter table. I see on table A, just, John again, both ones. So he has 2 orders on the right. Perfect. I see Trent, ID 3, because he has 1 order on the right. And then I see Tish, ID 4, 1 on the right. What I do not see Jane, and I do not see whoever customer ID 5 is in their salad order, because those don't exist in both tables, so they will not show up in an inner join. Okay, great. So once we've gone through that, now let's get into some real examples in SQL. If we remember back, we were using SQL Fiddle, that's SQL Fiddle, and I have this database I'm going to share with you. And just want to remind you, before you use any of your data or any personal data to you or your company, check out their legal language, and you're going to find that on their home screen, sqlfiddle.com, the cookie policy, privacy policy, and their legal policy. Please look at that before proceeding forward with this. I think it's a great tool, and it's a free and easy tool. And if you use our data set, which is completely fake, you can feel free and comfortable to use this tool along in the course. There'll be a link in the description for you to follow along. Remember from last time, we actually have our PTO coaching SQL course database, and we had a customers table, our salesperson's table, our product table, and then our orders table. And we have the schema, and then we have some data entries inside as well. So the first thing we're going to do, though, is we're going to try to do some of these joins. If we recall from last time, this is actually going to be our test data set using SQL Fiddle. So if you notice, we have our customers table, we have our salesperson's table, products table, and then the orders table. So this is all for us to use, and great. And now we can answer some questions by joining the data. As we saw and those Venn diagrams and those tables earlier, we can use that as a way to visualize what's happening. So the first thing we're going to do is an inner join. The objective here is to retrieve all the orders along with the corresponding customers and product details that all align. So we're going to do an inner join for all the orders along with the corresponding customers and product details. So let's do that. I always like to start with a select star, because you can always go back and just pick the columns that you want later. And let's say orders table as O is going to be my anchor table. And then I'm going to inner join with the customer table. And let's just make sure it's actually with an S, customers with an S, perfect. Also product with an S. These are good things to check because it really loves to spell check on you. Now I'm going to join this table on O.customer ID is equal to C.customer ID, right? So that's actually going to join there. And if you want to, sometimes you can even execute in the middle. Okay, great. I see all that coming out. But I also still want to add on one more table. I want to do another inner join with the products table as P. I'm going to do this one on O.product ID is equal to P.product ID. Now, the reason why I'm using these keys to connect the tables, because that's actually how you do the join. And luckily from last time, I remember that the product ID is also in the orders table, and the product ID is also in the products table. So with the schema you have, or just some outputs, you might be able to know all the columns available for you. Okay, so great. We can execute this and we'll get all of the inner join tables from order ID, and then you can see the customer names, John Doe, Emily Johnson, and then also the products, laptop, smartphone. But maybe I don't want to see all this information. I could whittle it down a bit, and let's say I just want the order ID. Then I might just want a customer, look like customer name, so just name, C.name. I might also want the product itself. So we'll just look at the product name. So, or even product ID. Let's go product ID. And then I might want the order date, so o.order date. And then lastly, I might want the sales themselves, o.sales. Okay, let's see if that runs. Okay, great. So now I have the order ID, the name of the customer who brought the order, which product they ordered, the date, and then the sales amount. So we see that all here, and we have these lovely inner joins that we're able to do that. Just to recap, so we're using the inner join in this case, and we use that to see only rows that matched in all of the tables or all in the orders table. And then, of course, you saw the alias we use this as. Our next example is actually to do a left join. That's a left join. And we're going to have the objective of listing all the customers and their order, if any. So all the list of all their customers and their orders, if they even have any. So let's try that out. So I'm thinking customers as a key table to anchor on, and then orders table, right, to look at as well. So starting here, I'm going to do a select star. And like I said, it's just really an easy command to keep handy. So I'm going to look at all the customers, and we're going to call it as the C table. And then I'm going to left join to the orders as the O table. And I'm going to do this on C dot customer ID is equal to O dot customer ID, right? So this will give me all of the orders there that do this left join here. So I can run through and execute. Okay, great. So now I see all of our customers and all of their orders. And even if they don't have any orders, I'm still going to get a list of all of the customer IDs. So 1, 2, 3, 4, 5, 6, 7, 8. I have those all. And it looks like actually everyone ordered. So that's good to know. Now, once again, if you want to shorten the columns that we're pulling over, you can just, let's say, pull customer ID, and then pull the customer name. You can just pull, let's say, their status. And let's say order ID, product ID. And then let's say sales, right? And you can see still pools and those pieces of those rows, but now I've actually have less columns, just the columns I wanted. Maybe I've have a particular report to do. Okay, great. So what we did here was a left join to return all the records from customers from that table, like the A side, and we match records from table B or the orders side. Now, customers without any orders will have a null value in the table itself. So this is useful for identifying customers who might not have placed orders yet. You can see where they're null and maybe where you want to ping them a little. Okay, for this next example, we're going to right join. So I'm going to list all the orders and include customer information showing all orders, even if customer details are missing. Now I'm going to actually continue this example and say, well, how would we change this example here and just include all the orders, even if customers are missing? Well, I go from doing a left join to just doing a right join. So this one's pretty simple. I'm just going to go from left join to right join. And even if there were some missing values for the actual customers, they're still going to be pulled in, and we're just going to pull everything from the orders table. So that's how you would do it. You go from left join to right join, and I would get everything in the orders table, even if the customer rows are missing. In our last example of today, we're actually going to do a self join. Now, this is something very interesting, a self join. So we can use the table and then join it to itself. So the objective will be to find pairs of customers from the same country. That's finding pairs of customers from the same country. Okay, so this is going to be really good to kind of figure out. So why don't you say select star from customers as C1. And then let's do an inner join with customers as C2. And we're going to join on that country equals C2.country. And to make sure I don't get duplicates in weird ways, C1.customer ID is not equal to C2.customer ID. Now, the little not equal to sign, these back and forth brackets here, I'm actually going to include in the cheat sheets, there's lots of little logical operators, but not equal to here, this. So let's see. Okay, great. So I have Jane Smith has the same country as John Doe, and then John Doe, same country as Jane Smith. So it's perfect, exactly what I wanted. Now let's look at the customer table, see if this is actually true. Okay, let's see here. USA, John Doe, and Jane Smith, yes. But does anyone else share a country? No, those are the only two that share countries. So that's perfect. Now, if I wanted to, this way I have two pairs. I could also do a less than sign and say customer ID is explicitly less than customer ID 2. And in this case, we execute, we'll only get one pair. We'll only get one pair, so John Doe and Jane Smith. So this is one way as well. So in this case, we actually can see that John Doe and Jane Smith share the same country. Now, a self-join on a table is useful for comparing rows within a table. Useful for finding relationships within any single data set. You just completed day 2, and I hope you paused throughout and went through those examples just like I did and really did those joins. You've now completed maybe 4, 5, 6, who knows, 10 SQL executions, and you're on your way to do even more in SQL. Tomorrow, day 3, we're going to tackle analytics. Sums, counts, averages, minimums, maximums. We're going to really dive in deep to understand SQL analytics, and it's only going to be day 3. So stay tuned and come on back.